Hello and welcome to episode 5, the Advanced IC Identifier in Series 2, the Power On series. So Mini, what can you tell me about the Advanced IC Identifier?
Sure, so the Advanced IC Identifier is one of the many instruments that come with the BoardMaster, and this specific instrument is used with the ATM, the Advanced Test Module. Now what this instrument allows you to do is find ICs that work in the same way as the IC you have in front of you. So this test looks at the functionality of the device, making sure that it's the same as the one we have in front of you.
Okay.
So we can do a quick demonstration here. So this is our Advanced IC Identifier.
Okay.
And we also need a power supply because this is a power on test.
Yeah.
And this is very useful, especially when you have house coded devices. For example, it may just say ABB or Siemens or something along the lines of that. So you don't know the specific part number of your device. So this is where the instrument comes in handy, so you can find devices that work in the same way as the device you have in front of you. And also with obsolescence management, for example, you may have a certain IC that is not readily available anymore. Can't find it, there's no supplies available, so you can use again the same instrument to find ICs that may be able to replace the one you have in front of you. So these are the different ways you can use this specific instrument.
Okay, can you demonstrate that for us, please?
Of course. So as I mentioned, we need a power supply. Obviously this is a power on test, and there's a few rules that we need to stick to when it comes to using a specific instrument. Obviously our board needs to be a good working board, as well as the IC needs to be perfect and working order. Otherwise it would not make sense to do this test. And this device we are connected to has 14 pins. So if you come over here, you can select how many pins your device is. So we choose 14 pins, and then we have a list of all the different families available within our software. So for example, we have the 4 series, 7.4, bus, connectors, linear, LSI, military. Well, we have many different packages. If you know which family your device is from, you can select that specific family. If you're not aware, then you can select as many as you want, and eventually the IC identifier will find a device that works in the same way.
Okay, fantastic. What are the advantages of choosing more or less families?
So if you choose less families, the test will run a little bit quicker, but again it will depend on the IC and how much information you have.
Okay.
So you can simply click start. And then once we click start, the system will look through the System Ultimate Library to find ICs that work in the same way. And as you can already see, we've identified 3 ICs. And
5?
5 now, exactly. The longer you wait, the more ICs will populate in the instrument itself. Is there any specific one you'd like to choose?
Keep it simple, the 5400 will do.
Okay, so we can use the 5400 device in the library to test the IC we have in front of us. So what I'm going to do now is click stop. So we'll stop the test here.
You can also see that just running the test, I can get the functionality of this device. So we've got notice that it is a quad 2 input NAND gate, so it's shown as all those.
So it gives you more information about the device, so you understand how it's meant to work.
Right.
Yeah. So let's close this instrument. Open up the Advanced IC tester over here. So the Advanced IC tester we covered in an earlier episode. If you'd like more information about that specific instrument, you can watch this video here. And in that video, we looked at the different tests available and how they work. So let's have a look at our instrument. We're going to set up to make sure everything is set up correctly. Okay, and then we can select our device. So again, as I mentioned before, there's a long family, a list of many different devices. And the one that you chose was the 5400.
That's correct.
Yep, so we can select the 5400. There we go, so we have found it. Yep, and again, power on test, so make sure our power is on. And then simply click start. And in a second, we should have some results. There we are.
Okay, fantastic.
So our IC is working as it should do, using the 5400 device in our library. So this works in the same way as the device we have. Okay,
brilliant. So we've just confirmed that the connections, and the functionality of the device is exactly the same as the device we have right in front of us.
Exactly, and this may be a house code. It might just say ABB on it, and
right.
Obviously we don't know what it is exactly. But now we have an idea of what it is or how it works.
Yeah. So if you're writing a bomb now, you can write 5400 next to that IC.
Exactly.
Okay, brilliant. What's this connector here?
Okay, so this is the auxiliary I/O connector. Now we use the BDO cable to connect here, and what we can do with that is sometimes you may find that you have an IC on your specific PCB,
right?
And with this IC you have incoming signals that are alternating, so you can have a clock signal coming in, for example. What this means is that your IC is not stabilized. Because it's not stabilized, we then cannot test the functionality of this device, because again, the high is jumping from high to low, the voltages are not stable, the incoming signal is not stable, and this will not allow you to do the truth table test. So before we can do the truth table test, we'll need to use a BDO cable to disable this signal, making sure our IC is stable and there's nothing incoming, nothing that can affect it before we run the test.
Okay, fantastic. Could you demonstrate that for us?
Yeah, okay, so this is the BDO cable. Okay, so this cable, you simply connect it as you would do any other cable that comes with a BoardMaster. So as you do, simply push it in like that.
Yep.
Okay, and on the other end of this cable we have several different clips and hooks. So we have 4 which are green, and these are used to send a low signal, and we also have 4 which are red. These are used to send a high signal. We also have 2 black crocodile clips which are basically our ground. So before I connect that, we can demonstrate on the 74161. So let me move my clip and just connect to now.
Okay, and does it matter the orientation of the clip?
No, it does not matter with this test. You can select it so it auto configures what pins are where.
Fantastic.
And then again, because this is a power on test, we need to make sure our power is on. Before I do that, I will just check that the instrument is set up as it should be.
Okay.
Okay, everything's fine. Turn on power.
Yep.
Like so, and then click start.
Okay.
So in a second, we should have some results. Okay, there we are. So as you can see, we have on pin 2 SIG, so SIG. So this is telling us that we have a signal incoming into pin 2 of our device.
Right.
And as you can also see, the voltages are alternating up and down. On the other side, from pins 11 to 15, you can see we have lows, you have mid-highs, you have a lot of things going on here. This is because our IC is not stable. And we could show more details in the logic trace. So if we move on into that. Okay, so we can see all the highs and lows once the test. There we are, just like that. And these red blocks here are showing us when our logic is not right. So when it's low, when it's meant to be high, or when it's high, when it's meant to be low. And you can see the voltages, specifically on pin 2, the clock signal changing, and you can see it moving up and down.
Okay, and that's irritating the device.
Yeah, basically our device is not stable.
So what will we do about that?
Okay, so as I mentioned, we use a BDO cable. In this example, we're going to send a low.
Yep.
We're going to send a low signal to disable this clock, to stabilize our IC. And as you can see, the truth table is failing, connection and voltage are failing.
Okay.
So we need to stabilize it before we can do those specific tests.
Yeah.
Okay, so if we keep an eye out on the test itself. Okay, so now that the cable's connected, we will see that everything should pass in a second, just like that.
Fantastic.
And now we can see nothing is jumping around, our voltages are fixed, our highs and lows are as they should be, and we can see that the truth table is also passing, as well as the connection and voltage, and everything is now stable. We can jump back into the IC display just to see how that looks now. So now we don't have no signal incoming into pin 2, and we don't have nothing interrupting our pins 11 to 15 as we saw before.
So that was a quick demonstration. We first began with the IC identifier, and then we showed that you can't really use that on an irritated IC. So we showed you how you can actually isolate that that chip using the BDO cables and the advanced IC tester. So stay tuned for the next episode where we'll be looking at the short locator.